So in this video we're going to be solving some exponential type equations, and it's going to often involve logarithms. So looking at problem number 17, of course our first step is going to be to divide both sides by 5, get rid of that 5. Okay, so do that. Bless you. Bless you, darling. So that gives me e to the 2x power plus 3 equals 12. Alright? That's as far as we can go using regular algebra skills. Any idea what I'm going to do now? Right, you got to put it in natural log form. I like how you knew it was going to be the ln. Okay? Let's go for the natural log. So in log form, we always start with the base. So this would be log base e, which of course is going to be natural log. I'll write it this way for a second. So we always start with the base. And then these other two parts switch sides. So the 2x plus 3 and the 12 are going to reverse. So I'm going to have the 12 over here and the 2x plus 3 over here. I have a feeling that it's going to require the TI-30. Okay, so log base e, that's natural log. So we have natural log 12 is equal to 2x plus 3. So now we're back to algebra skills again. So to get that x by itself, we'll subtract 3, divide by 2. So I'll subtract 3 on both sides. That'll give me natural log 12 minus 3 is equal to 2x. Please don't subtract the 3 here and get 9. It doesn't work like that. Now I'll divide by 2. Alright, so this is not a 4-function calculator type problem. You need your multi-view. Okay, but we can get the answer now by just putting this into our TI-30XS multi-view. Help me remember the problem. So I'll go right into fraction mode. So natural log 12, I'm going to definitely close that parentheses, minus 3 over 2. Okay. So this is what we have. So I'll do 2 decimal places. So negative 0.26. Okay, so that's how you do number 17. Any questions right there?
Yes.
So in number 18, we're going to have to expand and condense. Well, condense. So first of all, everywhere you see a number in the front, let's use the power rule and put that coefficient as an exponent. So this 3 is going to become third power. This 4 is going to become fourth power. This 2 is going to become squared. And this 2 right there is also going to become squared. Okay? So, let me recopy, I guess. Now, I see these 3 terms here. I can combine all 3 terms on the left side into one term using a combination of the product rule and the quotient rule. Sort of like we did earlier. I'm just going to do this. I'm going to write log base 2, and I'm going to make my fraction. Anything that's coming from a positive term is going to end up in the numerator. Anything that's coming from a negative term is going to end up in the denominator. So my 64 and my 81, those are both from a positive term. So I'm going to have 64 times 81 in the numerator. My x squared is sitting here in a negative term, so that's going to wind up here in the denominator. And that's all equal to log base 2 of 36. Okay? What is 64 times 81? Help me out. 5,184. I'm just going to erase this and put that. Alright, 5,184. See, since we have log base 2, blah, 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 equals log base 2 36. We can drop the log base 2 part. The argument, the thing that you're taking the log of, those two expressions have to be equal to each other. So we can just go ahead and make that logical jump. Let me change colors though. I think I'll use green now. So making that logical jump, we have 5,184 over x squared must equal 36. All right, did I lose anyone on that step just then? Okay. What do you think I'm going to do now? Jump in.
You replace the denominator with 36, so you have x on one side.
Yeah, remember, this shortcut just shows up over and over and over again in lots of different places. The quickest thing to do is understand we can reverse the x squared and the 36 if we want to. All right, so let's do that. In fact, I'm going to cheat and just do it right here. So x squared and 36, I'm going to swap those. So the 36 will end up down here, and my x squared will end up over there. Okay, I'm betting that 36 divides evenly into 5,184. Am I right? 144. Okay. So that means 144 is equal to x squared. So taking the square root of both sides, don't forget it's plus or minus. So that's plus or minus 12. Okay. However, the negative version is extraneous because you can't take the log of a negative number. So x can't be negative in this case because if you look back at the original problem, right here, we have the log of x. So x itself can't be negative because you can't take the log of a negative number. So that means the answer is only 12, only positive 12. All right, so that's number 18. Any questions on number 18? All right, number 19. All right, so number 19. So we need the common base like Marash and I were talking about. Both of these can be written with a base 2, with a base 2. Because 8 is 2 to the third power, and 16 is 2 to the fourth power. All right, so they're both base 2. Meanwhile, I still have the 2x minus 1. Let me spread this out. I'll put the 2x minus 1 in parentheses, though. And here I have my 2 to the fourth power, and I'll put my negative 3x minus 5 in parentheses. If the bases are the same, then the exponents are the same. I'm going to go ahead and do the distributive property, but I'm just setting these exponents equal to each other. So this would make 6x minus 3 is equal to negative 12x minus 20. So now we're back to just algebra. So I would add 12 to both sides. So that's going to give me 18x minus 3 is equal to negative, 20. So I will add 3 to both sides. And I will divide both sides by 18. And there's no need to make a decimal. You can just write x equals negative 17 over 18. All right, any questions about number 19?
Are you sure it's 18?
Oh.
Shouldn't be 17.
So looking at number 20, we're going to have to use the product rule. When you have two logs and you're adding, you put them together, you multiply. So I'm going to write this as one log expression, but I'm putting it together as multiplication. So I'm doing x times x plus 3. Okay, so of course that's going to make x squared plus 3x. Okay, we're going to have to write this in the other form, exponent form. What's the invisible base right now? Yeah, there's an invisible 10 right there, but we need that. So in exponent form, the first thing we do is write down that base of 10. Everything else is going to change sides. So this and this are going to switch. So the 1 is going to come over here and become a power. And the rest of this is going to come over here. So it'll be x squared plus 3x, like that. Obviously 10 to the 1 power is just 10. So I'm going to subtract that 10 from both sides and try to factor. So what I have is 0 equals x squared plus 3x minus 10. So I'm going to try to factor this now. Good luck. X squared can only factor as x times x. 10 is either 10 times 1 or 2 times 5. Obviously, I'm going to try the 2 and the 5. Remember, inner plus outer must equal middle. Inner, I have 2x. Outer, I have 5x. To get a positive 3, I need a negative 2 and a positive 5. So there's my negative 2. Here's my positive 5. That does make negative 10, so we're good. But we're solving. Whoa, that's not an eraser. So I take these factors and I set them equal to 0. Whoa. Glitching so bad. Bootleg. It's a trick. I'm going to ignore it. So x minus 2 equals 0. And x plus 5 equals 0. So that'll give me x equals 2 and x equals negative 5. Are either of these extraneous? Do I get to keep both of these solutions? The negative 5 is going to be extraneous, guys. Don't assume just because it's negative, but in this case, looking back at the original problem, we had log of x. You can't take the log of a negative number, so in this case, x cannot be negative 5. But the 2 is okay. So x equals 2 is our only answer. All right, so looking at number 21. Let's go ahead and combine these together. This 2 is going to have to jump over and become the exponent like you do. That's too big. Now, you have that, but also understand, let me scribble that out harder. Using the product rule, we can put these together as one expression by doing the product. So I will do log base 5 of 2x squared. I bring it together. Okay, log base 5 of 3 minus x. Now that I have the log on both sides, I can set the part in the parentheses equal to each other. So that's what I'm going to do. So I have 2x squared equals 3 minus x. Let's get 0 on one side and try to factor something. So I'm going to subtract 3 and add x. So minus 3 on both sides. Okay. So add that x on both sides. Okay. So that's going to give me 2x squared plus x minus 3 equals 0. Hopefully this is factorable. we shall try. 2x squared can only factor as 2x and x. 3 can only factor as 3 and 1. Okay. Inner plus outer equals middle. Right now, inner, I have 3x. Outer, I have 2x. I'm trying to get positive 1. I can get positive 1 if I have a positive 3 and a negative 2. So here's my positive 3, and this will give me the negative 2. Also, I'm going to get negative 3 out of it, so that's cool. So this is the correct factorization. Any questions so far? So 2x plus 3 equals 0. X minus 1 equals 0. Alright, of course we'll solve this from here as we normally would by subtracting 3 from both sides and adding 1 to both sides. So that'll give me 2x equals negative 3. And over here I'll have x equals 1. And if we divide both sides by 2, then I have x equals negative 3 over 2. Now be careful, this one is extraneous because remember you can't take the log of a negative number, so x can't be negative in this case. So this one's extraneous. So x equals 1 is our only solution. Alright, so number 22, we need to subtract 4 from both sides. So that's going to give us log base 9, 3x minus 7 is equal to 2. Alright, that's all you can do algebraically. We have to switch over and write it in the other form. Always start with the base. So I'm going to bring down my base of 9. Everything else has to switch sides. There it goes. So this and this. Okay. So obviously this is 81 is equal to 3x minus 7. So this is back to straight algebra. Add 7 to both sides. So that's going to be 88 is equal to 3x. Divide both sides by 3. So x is equal to 88 over 3. Alright, any questions on number 22?